Hello everyone, welcome back to the No Mr. Science channel. Now let's go for our solution step by step. Replace the force and couple moment system acting on the rectangular block by a wrench. Specify the magnitude of the force and couple moment of the wrench and where its line of action intersects the XY plane. So first, I identify the forces we're gonna use. I'm gonna call F1 the force minus 450 in the direction I, and the units pounds. F2 our 600 J pounds, and our F3 is gonna be 300 K pounds. So to find the force, I'm gonna do the resultant force is equal the sum of the forces 1, 2, and 3. So our resultant force in a vector form is minus 450 I plus 600 J plus 300 K. Now we're going to find the magnitude as the question asks. So the magnitude of the resultant force is equal the square root of minus 450 square plus 600 square plus 300 square. So the magnitude of our resultant force is 807.8 pounds, or if you prefer, the resultant force is equal 808 pounds. Now we're gonna find the moments that our forces do in our block. So we're gonna use basically our moment equation, that is the cross product between the distance vector and the force. So to recall, our force 1 is minus 450 I pounds, and then I'm gonna find the vector distance 1, that's equal. The distance that we're gonna find is the distance between the origin of the force to the XY plane, as the question asks. So here our first distance vector is 3 minus x I plus 4 minus y j plus 2 minus 0 k. So to proceed our moment, we're going to build the matrix I, j, and k. Here our distance vector 3 minus x, 4 minus y, and 2, and here our force minus 450, 0, and 0. I'm just gonna put the result, and then I'm gonna put a card and how we solve the cross product. So our moment 1 is equal minus 900 J plus 450 times 4 minus y in the direction k. So here we're gonna proceed for our 2 and 3. So our F2 is equal 600 pounds. So our R2 is equal 0 minus x I plus 4 minus y j plus 2 minus 0 k. So our matrix for M2 would be I, j, and k. our vector distance is minus x, 4 minus y, and 2, and my force is 0, 600, and 0. So our m2 in the vector form is minus 600 x k minus 1200 I. Our R3 is equal 3 minus x I plus 4 minus y j plus 0 k. So our matrix for moment 3 is I, j, and k. Here I have 3 minus x, 4 minus y, and 0, and here I have 0, 0 and 300. So our moment 3 in the vector form is equal 300 times 4 minus y I minus 300 3 minus x j. This is our moment 3. Now we have our 3 moments that we just discovered, and now we're going to discover where and how our resultant moment is in Cartesian vector. So I know that our force is equal minus 450 I plus 600 j plus 300 k, and our magnitude is 808 pounds. So what we can do is find our unit vector r, that's equal minus 450 over 808 I plus 600 j over 808 plus 300 over 808 k. So our unit vector is equal minus 0.557 I plus 0.743 j plus 0.371 k. Why we had to find the unit vector? Because we know the resultant moment in Cartesian vector is the magnitude of the resultant moment times our unit vector. So here our resultant moment we can split in mx is equal minus 0.557 the resultant moment. In y we have 0.743 mr, and for our mz is equal 0.371 k. So from recall our previous slide, we have m1 is equal minus 900 j plus 450 4 minus y k. m2 is equal minus 600 x k minus 1200 I. Our m3 is equal 300 4 minus y I minus 300 3 minus x j, and our m4 it's gonna be 600 I, that is this one. This is our m4. Now in the next slide we're gonna split in mx, my, and mz and find our resultant moment. So here for the x-axis I have minus 1200 plus 600 plus 300 that multiplies 4 minus y is equal minus 0.557 times the resultant moment. So here I'm gonna call the equation 1. For the y-axis I have minus 900 minus 300 times 3 minus x is equal 0.743 resultant moment. This is our equation 2. For z we have 450 times 4 minus y minus 600 x is equal 0.371 times the resultant moment, and then I'm gonna call equation 3. So here we have 3 equations and 3 unknowns. My unknowns I'm gonna use 4 minus y, just x, and then here our resultant moment. So here from equation 1, I have that 4 minus y is equal 600 minus 0.557 times the resultant moment over 300. And from equation 2, I have that x is equal 0.743 times the resultant moment plus 1800 over 300. So here is our 2 unknowns that I'm gonna insert in the last equation, equation 3. So if I plug this in the equation 3 I have 450 times 600 minus 0.557 resultant moment over 300 minus 600 times x, that is 0.743 times the resultant moment plus 1800 over 300 has to be equal 0.371 times the resultant moment. So here we have the equation that we're going to find the resultant moment. So for the next slide we're going to continue in this equation that I'm going to call 4. So recall 4 from our last slide. So here we're going to have 900 minus 0.836 times the resultant moment minus 1.486 times our resultant moment minus 3600 is equal 0.371 resultant moment. So here we have 2.69 times our resultant moment is equal minus 2700. So the magnitude of our resultant moment is equal minus 1004 pounds-feet. So here is our resultant moment. Now we're gonna use this value for our resultant moment to find x and y. So I'm gonna put the value and insert in our equation 1. So recall equation 1. So I have minus 1200 plus 300 times 4 minus y is equal, plus 600 is equal minus 0.557 times minus 104. So here I have that our 4 minus y is equal 3.864. I have y is equal 0.136 feet. And then to finalize for our equation 2, so recall equation 2, we have minus 900 minus 300 times 3 minus x is equal 0.743 times minus 1004 pounds-feet. So here I have that my x is equal 3.51 feet. So here we found everything that the question asks. We have the resultant force that's equal 808 pounds. The magnitude of moment is 1004 pound-feet, and the line that intersects the xy plane is x is equal 3.51 feet and y is equal 0.136 feet. Thanks for watching until the end. Don't forget to like this video and subscribe on the channel. Thank you.